Hello everyone, this is Azam here, and today we'll be doing exercise 1B from the higher level Oxford textbook for um, analysis and approaches. So let's go ahead and get started. I hope you enjoyed the last video. We switched it up a bit. I'm on a white screen now because my app the other day took away my access. So yeah, this is what I have to rely on now. Exercise 1B. Let's go ahead and get started. So this exercise, basically doing the same thing from last video almost. We're introducing a couple of word problems. But 1A, we're finding the nth term of each of these sequences. And when it says that, it's just asking us to give us, the general term basically. 1A, we have 3, 8, 13, and 18, dot, dot, dot. And each of these are increasing by 5. So our common difference is going to be 5. So then we get the general term. Un is going to be equal to u1, which in this case is 3, plus 5, n minus 1, just like that. Okay, 1b, we have 107, 97, 93, 89, just like that. All right, and as I said from last video, we must recognize that this is a decreasing pattern. Our u1 term is 101, so we can go ahead and already write un going to be equal to, oh, sorry, our u1 term, yeah, it's 101. I accidentally wrote that as 107. Let me just erase that. Minus, and let's find the common difference here. Looks like it's just going to be minus 4 every time. So minus 4 and minus 1. And when we simplify this, we end up just getting 105 minus 4n. You don't have to simplify it, but it does make it look a bit cleaner. 1c, we have a coefficient, or sorry, a variable this time, a minus 3, a minus 1, a plus 1, a plus 3. So just taking out the a from here, we know that u1 is going to be equal to a minus 3. Now let's find the common difference between all of these. Looks like, once again, it's just a simple arithmetic plus 2 every time. So we know it's going to be plus, sorry, plus n minus 1, 2, just like that. And 2 is our difference here. I just wrote it backwards. Usually I would write it here, but I blanked out for a second. And then that ends up just simplifying to a plus 2n minus 5. Okay, 1d. Let me actually find a way to get this out of here. There we go. Perfect. Okay, 1d. Negative 20, negative, whoops, negative 5, 10, 25. Okay, we start at a negative number, but we increase. Once again, we know our u1 is going to be equal to negative 20, and simple arithmetic, our difference is just going to be plus 15 each time. So plus 15 n minus 1. Simplifying this, you end up getting 15n minus 35. Okay, number 2. We have to find the indicated term that it's asking us about. 2a, we're given a sequence, and then it asks us about a specific term. So yeah, 5, 11, 17, and 23. Here it asks us about our 15th term. Since these are sequences, we can just find a general term of this and then plug in 15, and that'll give us our answer. So the general term here is going to be un, going to be equal to 5, also known as our u1, plus common difference here, which is 6. 6 and minus 1. Now, since it's asking for our 15th term, our n is going to be equal to 15. So u15 is our 15th term. 5 plus 6, 15 minus 1, which gives us 89. To B, 10, 3, -4, and 11, a decreasing sequence, and we're asked to find the 11th term of this sequence. Since we know that un is going to be equal to 10 minus 7 each time, so minus 7 and minus 1. Whoa, where'd those dots come from? Okay, whatever. All we need to do is plug 11 into here now. 11 is going to equal to 10 minus 7, 11 minus 1, which is just going to be equal to -60. Just like that. To C, we're given a variable this time, just like earlier in exercise 1, and we're asked to find the 17th term. Okay, our difference here is just going to be +2 every time. So un is going to be equal to a, or u1 term, plus 2, but not a minus 1, and minus 1. And our 17th term is going to be u17 is equal to a plus 2 times 17 minus 1. And that just gets us a plus 34. Okay, the last one for 2 is going to be 2D, given the sequence of a decreasing pattern. But instead of asking us for an integer term, it actually asks us to find the n plus 1 term. So before we complicate things, let's get this solved out. Our u1 term is 16, our common difference is 4, or I should say -4. So we can already write out a general term of un is going to be equal to 16 minus 4 and minus 1. Now, when it asks for an n plus 1 term, we can write it like this. Now, it's not asking us to put n equals 1 into this equation. It's asking us to put n is equal to n plus 1. So to continue on from that, that would end up giving us n plus 1 minus 1. Let's see how those two correlate? Just like that. From there, oops, let me cross that out. There, we know that the un plus 1 term is going to just end up equaling 16 minus 4 n. Just like that. Okay. Next up is 3. 3a asks us to find the number of terms in each of these arithmetic sequences. I haven't actually mentioned this, but when it says arithmetic, that means we know it's going to be addition or subtraction. So you don't have to worry about, finding some crazy ratio going on. So let's just start here. 16, 11, 6, dot, 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 -64. So we need to actually find out how many terms are in this entire sequence. It is a limited sequence, so we can find out easily by creating a general term once again. Remember the rules for the general term. And we are subtracting 5 each time, so our difference is going to be 5. And that ends up simplifying to -5n plus 21, if I'm not mistaken. But we don't even need that simplification. Since we're solving for our nth term, we can plug in un as 64. It's going to be equal to 16 minus 5 n minus 1. And after doing some simplification, we get that n is going to be equal to 17. So we know there are 17 terms in this sequence. B, yeah, 3b. We have negative 108, 104, negative 94, dot, dot, 60. All right, looks like this n is going to be a bit longer than the last one. We have this entire thing going on over here. So let's get to solving. Let's create a general term of un is going to be equal to negative 108. And looks like we're going up every time with a common difference of, oh, did I write that right? Oh, I did not. That makes sense. Okay. This is a 1. Sorry. Oh, I didn't know you could do that. Okay. Yep. That's a 1. Looks like we're going down by a common difference of 7 each time. And when I say going down, I mean increasing. Sorry. So it's going to be plus 7 and minus 1. And that gets us equation un is going to be equal to 7n minus 115. Let me make sure that's right. Yep, all good. Okay, now we're trying to find how many terms there are. So we take the last term, which is 60, plug that in for un, and we solve this formula. And by doing all the math, we get that n is going to be equal to 25. 3c, we get negative 15, negative 19, 23, dot, dot, dot. And our last term is negative 95. Okay, so we already know it's going to be a decreasing sequence with a difference of negative 4 each time. So let's write this out. Plug in our last term for our nth term. So we get negative 95. It's going to be equal to negative 15 minus 4 and minus 1. And now adding 15 to both sides, divided by negative 4, and then adding 1 once more, we get that n is equal to 21. Next is going to be 3D. Here we're introduced to a couple of variables. So we have 2a. Let me write that a bit separate from each other so it's not as confusing. We have 2a plus 5 is our first term. And already I can tell we have a common difference of negative 2 for each of these. Dot, dot, dot. Oh, can this line get out of here? Okay. 2a minus 23. So, as I said earlier, common difference is negative 2. And our u1 term is 2a plus 5 minus 2 and minus 1. Then we plug in our last term as our nth term. So 2a minus 23 is going to be equal to 2a plus 5 minus 2 and minus 1. After doing the simple math, we can cancel these two out. Minus 5 on both sides. So negative 28. Divide by negative 2 on both sides. We get n is equal to 15. So 15 terms. All right, that's going to be all for the third one. Number 4 looks like got to do a bit more work. Just scroll down here for A. It is asking us to determine the first term and the common difference of the arithmetic sequences that are generated by each of the following nth terms. Okay, let's go ahead and just write out for A first. Un is going to be equal to 5n minus 7. The first term comes from when your n equals 1. So for all of these, we can just plug n equals 1 in. U1 is going to be equal to 5 times 1 minus 7, and that's negative 2. And then next we need to find the common difference between all of these. You can do this by finding the second term and then just finding the difference between that, since we know it's an arithmetic sequence. The second term is going to end up being 5, 2 minus 7, which is equal to 3. And then the difference between negative 2 and 3 is 5. So D is going to be equal to positive 5. And that is our answer. Next, 4b. We're given 3n plus 11 is equal to un. Then remember, first term is just going to be when we plug n equals 1, and we get 14. To find our common difference, we could do what we did earlier, but that was just an example. We know the common difference is going to be 3, since that's what our n is being multiplied by. So D is going to be equal to 3. I just wanted to show that this was also a way to do it, but you can easily recognize that that is that. 4c, we have un is going to be equal to 6 minus 11n. You know, our common difference already is negative 11, since that is what n is being multiplied by. U1 is going to be equal to 6 minus 11, which is in turn equal to negative 5, decreasing series. For D, I'm going to end up having UN equal to 2A plus 2N plus 1. As we said earlier, anything that n is getting multiplied by is going to be our difference, so it's going to be 2 this time. And to find our first term, once again, just plug in all the numbers, and we know it's going to be equal to 2A plus 3. Simple as that. Let's go on to number 5. Let's create some space for this. So, number 5 is a word problem. We're given that the sixth term of an arithmetic sequence is 37. So let's go ahead and write that down. U6 is going to be equal to 37. We know that the common difference is positive 7. And it's asking us to find the first term and the nth term. So first term and the general term of this sequence. We can write every sequence as u1 plus d times n minus 1. So let's go ahead and write this one like that. You know that u1, well, we don't know what u1 is in this case, but we do know the n term is 6, so you can write it like that. We also know that u6 is equal to 37, and that our d is going to be equal to 7. Oh, just dropped my pen. All right. So now we know that u1 is going to be equal to 37 minus 35, which is equal to 2. But that's not all yet. We need to actually find a general term for this. Remember, a general term is just going to be equal to u1, which is 2 in this case, plus our common difference of 7 n minus 1. Which just simplifies to 7n minus 5. Okay, number 6. Number 6 asks us to find the fifth term in an arithmetic sequence. Oh, sorry. Number 6 is asking us that, restart. All right, number 6, we're given that the fifth term of an arithmetic sequence is 0 and that the 15th term is equal to 180. Asking to find the common difference and the first term. So let's just set that down for now so we know what's going on. All right. Here we're going to have to set up an equation using both of our terms that we have. The fifth term, 0, is going to be, get out of here. Okay, so what this is telling us is the fifth term, 0, is going to be equal to u1 plus 4d, and that the 15th term is going to be equal to 180, which is equal to u1 plus 14d. Okay, from here, let's subtract these problems from each other. So let's write it like this and like this. The reason why we're subtracting is because we want to get rid of these u1s so we can find the common difference. And by doing that, we get 180 is going to be equal to 10d. So d is equal to 18. Boom. That's our common difference. And from there, we can find our u1 term easily. We just need to plug d back into one of these equations. Let's do the u5th term. So u5 is going to be equal to 0, which is equal to u1 plus 4d. In this case, our d is 18. And from that, we get u1 is equal to negative 72. That is our answer. Okay, let's set our three terms equal to un, then un plus d as our second term, and un plus 2d as our third term. Let me zoom in real quick. Oh, great, those dots are back. Okay, we know that the sum of these three terms are going to equal 24. 24 is equal to un plus d plus un plus 2d. This ends up giving us this equation right here. So that means un plus d is equal to 8. Hold on to this equation for a second, and let's go to our product. We're giving this for the product that the product of all three of these equals negative 640. And look right here, we can plug this into here, and we want to get rid of the difference here. So instead of making this into un plus, d plus d, we're just gonna plug in d as 8 minus un. And after substituting, we get un times 8 times un plus 2, 8 minus un, which is all just equal to negative 640. After simplifying even more, we get 8 un times, let's see, what's this equal to? Negative un plus, oh great, dots back, great, plus 16 is equal to negative 640. From here, we're going to divide on 8 by both sides to simplify it even further. Then we get this equation. Okay, from here we have to create a quadratic equation. And with this quadratic equation, we get 16 un minus un squared is equal to negative 80. Now that we're here, let's create a quadratic equation by adding 80 to both sides and then dividing the entire thing by negative 1 just so we can make the un squared positive. So then we get un squared minus 16 un minus 80 is equal to 0. And then after factoring this out, we should get un minus 20 times un plus 4, which is equal to 0. And now we're given that un is either going to be equal to 20 or negative 4. Can't equal both, can only equal one. So we have to go back over here. We have to basically plug these two in and see which one works. So let's let un equal negative 4. If this were the case, that would mean that d equals 12. And the reason I'm saying that is because, where's the equation? Oh, it's far. If we plug this back into here, we get d is equal to 8 plus 4, which is equal to 12. And that would mean the four numbers end up being negative 4, which is un, and then plus d, or plus 12, 8, and then plus 12 again, 20. But if u1 is equal to 20, we know that d is going to be equal to, let's see, 8 minus 20 will be equal to negative 12. So then our four numbers would end up being 20, 8, and negative 4. Would you look at that? Flipped around. Let's see, what else did it ask us? This is your answer. Since d can either equal plus or minus 12, we can just plug these in and these could be the three numbers. They're the exact same. So yeah, these are your three numbers, either 20, 8, and negative 4. All right, going on to number 8. That one was a bit confusing, but it should get simpler after this. Let me zoom in a bit. We're given that Jung Ho earned $38,000 when he started his first job in the year 2000. He received a raise of $500 for each consecutive year. Determine how much he earned in 2017, and then evaluate in which year he would earn 50% more than his original salary for the first time. Okay, so we know that U1 is going to end up equaling 38,000 because that's the first year when he started working his job in 2000. We know that each year he gets 500 more dollars. We're given that. So we know the difference is going to be 500. So from here, we can already set up an equation that the nth term, or how much money he makes in 1 year, is going to get given by 2,000, well, the salary in 2,000, which is 38,000, plus 500, n minus 1. And then from here, we might quickly go into it and say, oh, well, just plug in 17 to get 2017. No, you'd actually be wrong here. Because if we plug in 17, we're going to end up getting 2016. So we got to plug in 18. And plugging in 18, we get this. And we get the amount of money he made in 2017 salary to be equal to 4,600, or sorry, $46,500. It's not over yet though. We need to find out in which year he actually started making 50% more than his beginning salary. To do that, let's first find out what 50% more from his beginning salary was by multiplying by 1.5. It gets us 57,000. Therefore, to find the year he started making that much money, create a less than or equal to equation. Oh, sorry, that should be 500 n. 7,000. I put the comma wrong. Okay, minusing 38,000 from both sides, and then dividing by 500. We get that n has to be less than or equal to 38. So that means the year is 2038. 8. Whoops. Yep, 2038. That's when he starts to make 50% more than what he started with. Okay, number 9. Number 9 asks us to find the value of each of the following series. So giving us a bit of lighter work this time. Just doing simple math here. Given that the U1, oh, sorry, let me cut this out. Okay, so we're given the series 3, or this is a sequence actually, but 3, -3, -9, -15, all the way to -93. Okay, so we know that U1 is going to be equal to 3. And then our difference here, which is subtracting 6 each time, so that's equal to -6. From here, we actually do need to find n. So we know how many terms are in here. We know that our last term is going to be negative 93, so that's going to be equal to u1 minus 6 and minus 1. Now after subtracting 3 from both sides and divided by negative 6 and adding 1, you get n is equal to 17. And now this is where our summation formula, or yeah, sum formula comes in. Remember that Sn, the sum here of a series from one term to the next term, whichever term you choose, is going to be n divided by 2 times u1 plus un. This will be in the formula book for the test, so it's not something you should, try to memorize, but it's good to have this in your mind. Now from here, we just plug in our numbers. Sum is going to be equal to 17 divided by 2, u1, which is 3, and then plus un, which is our 17th term, negative 93, so minus 93. So the sum, the first 17 terms, that's supposed to be a 17, is going to equal negative 765, just like that. Okay, 9b, we're given the numbers, let me find it, 31 plus, okay, hopefully that zoom in helps. 31 plus 40 plus 49 dot 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 plus 500 and ooh 517. Okay. Hold up, lost my step here. Okay. U1 is going to be equal to 31, and our common difference here is just plus 9 each time. Let's go ahead and find this nth term. Now that 517 is going to be equal to 31 plus 9, blah blah blah. Doing some math, we get that n is going to be equal to 55. And then remember our equation from earlier. This one, s the 55 is going to be equal to 55 divided by 2 times our first term, 31, plus 517. Looks like this is going to be a bigger number. It's going to be equal to 150, yeah, 15,070. Okay, 9C, almost done. This time we're given variables once again. I always hate when they give variables because it's just confusing, but be prepared. You'll see a lot of variables in the future. A lot. Okay. Dot dot dot. And the last term is a plus 146. Okay. U1 is going to be a minus 1. Difference is going to be 3. Sorry for the blank for a second. All right. Let's go ahead and find the nth term here. So a plus 146 is going to be equal to a minus 1 plus 3 times n minus 1. These two cancel out from both sides. Doing the math, you get that n is equal to 50. And the sum of the first 50 terms are going to be equal to 50 divided by 2 times a minus 1 plus a plus 146. Doing some math here, we get 25. Oh, there's the equal sign. 25 times 2a plus 145. So the sum of the first 50 terms is equal to 50a plus 3,625. Boom. Okay, number 10. Let me find it real quick. Okay, number 10 is just asking us to find the value of each of the following sums. And it looks like there's only 3 sums here. So let's get started. We're basically going to be doing the same thing we did from last time, but let's just go ahead and write this out. We have the summation from r equals 1 to 50, so the first 50 terms of the series 3r minus 8. So evaluating the sum of all this, we know that u1 is going to be equal to 3, 1 minus 8, which is equal to negative 5. And then un, also known as u50 here, because that's our last term, is going to be equal to 3 times 50 minus 8, which is equal to 142, if I'm not mistaken. Double check that. Yes, okay. So now we can write the sum out like this. Sum of the first 50 terms is going to be equal to n, so 50 over 2 times negative 5 plus 142, which should get you 3,425. Sorry, 10b. Jeez, that's 10, right? Yeah, okay. Okay, now let's go on to 10b. We have the summation of 100 from r equals 1 of 7 minus 8r. Okay, we're just going to do the exact same thing we did from last time and find u1, which is equal to negative 1, and then the last term, u100, which is just going to be equal to negative 793. And using our formula, we know the summation of the first 100 terms is going to be equal to u1 over 2 times u1 plus un. Sorry. I just realized. Okay. I was about to say, well, what did I do wrong? That not u1, not u1. The number of terms in this in the series. Okay, yeah, 100 divided by 2. Okay, there we go. Jeez, I was about to say. Okay, and that gets us 39,700. Oh, sorry, negative 39,700. Okay, 10C. Repeat of last time. They love to do this when they introduce variables. Okay, how do I get this off my screen? There we go. Yeah, they love to just introduce variables at the end, but we're not afraid of them. R equals 1 to 20, so find the first 20 terms of 2ar minus 1. u1 is going to be equal to 2a times 1 minus 1. And then u20 is going to be equal to 2a 20 minus 1. And simplifying that, you just get 2a minus 1 and 40a minus 1. Okay, now let's do the summation formula once more. 20 divided by 2, 2a minus 1 plus 40a minus 1. And that gets us 420a minus 20. That is number 10. Number 11 now. So to the next page. 11a. We're asked to find the sum of the following sequences up to the term indicated. Okay, we're told to find the sum up to the 15th term of the series right here. You know that u1 is going to be equal to 4, and the difference is going to be equal to negative 5. We actually don't need to end up finding the 15th term in order to do this formula. We can just plug these numbers in, and I'll show you why that works. So it's going to be uh, 4, which is our u1 term, plus, and we can literally just create the formula from here now for our u2 or u15th term. plus -5. Well, actually, I should just make that a -5 minus 5 over 14, which is then just going to be equal to 15 over 2, 2 times 4 minus 5 times 14, which gets us -465. Okay, 11b, let me write it down. We have to find the summation of the 10th term of the sequence 3, 11, 19. Once again, this is an arithmetic sequence or series where A equals 3 and D is going to be equal to 8. Doing what we did last time, the summation, the 10th terms is going to be equal to 10 divided by 2 times U1, 3 plus 3 plus 8, 9. Simplifying that, we get 3 times 2 plus 8 times 9, which is equal to 390. Okay, 11c. We have to find the summation up to the 20th of 1, -4, -9. Once again, another arithmetic sequence where u1 equals 1 and the common difference is -5. Using our formula once more, 20 divided by 2 times 1 plus 1 plus, well, I should make that plus, -19, which is just equal to 900 or -930. Okay, number 12. We have a world problem here. When you calculate the sum of an arithmetic series with 25 terms, given that the fifth term, so u5, is going to be equal to 19, and that the 10th term is equal to 39. Okay, so let's just put these in their general forms. You know that u5 is going to be equal to, oh, that's a bit too much. It's going to be equal to u1 plus 18d. That u10 is going to be equal to u1 plus, oh, what I messed up. Oh, yeah, that's where I messed up. That is not 18d. That is 4d plus 9d. Okay, and then from here we can just subtract these to get rid of the u1. So let's bring these down here. Let's flip these over like upside down. So we get the bigger number subtracted first. 39 going to be equal to u1 plus 9d minus 19 is equal to u1 plus 4d. If I'm not mistaken. Yep. These cancels out. We get 20 is going to be equal to 5d. D is equal to 4. And then from there, we can come back to our original equation or just get a random one from here. We can do u10. So 39 is equal to u1 plus 4, 10 minus 1. And after subtracting, we get that u1 is equal to 3, if I'm not mistaken. Yep, u1 is equal to 3. Okay, but we're not done yet. We need to go and find the summation of up to 20, it said. Let me check that. Yep, the first 25 terms. Okay, easy enough. So the summation from is 25 divided by 2 times u1. And once again, we don't need to find the 25th term. We can just plug it in like this. Remember that our common difference is 4, 4. Now after some simple math, we get that the summation is equal to 1,275. Okay, let's get some more space for 13. 13 is split into two parts. The third term of an arithmetic sequence is -8, so let's write that down. And the sum of the first 10 terms of the sequence is 230. Okay. Okay, let's put this in. We know that u3 is going to be equal to u1 plus 2d, which is equal to -8. And the summation of the 10 terms is going to be equal to 10 divided by 2, u1 plus u1 plus 9d, which is equal to 230. And doing some math, we can we can divide each side by 5 to get rid of this. So I'm going to get -46 is going to be equal to 2u1 plus 9d. And that helps us up by a lot, actually. From here, we can end up subtracting these two equations from each other. But we do need to actually multiply our u3 equation so we can take out the 2u from it. But let's first just write it down right here. -8 is equal to u1 plus 2d. And multiplying by 2 on each side, we get -16 is equal to 2u1 plus 4d. And then from there, we're going to subtract it from this bottom equation, this equation. And then looks like it's just simple addition. These cancel out. We get, it's at 30. Yeah, 30 is going to be equal to -5d. D is equal to -6. Boom. One step there. Now we just come back over here. This equation, -8 is equal to u1 plus 2, -6. u1 is equal to -8 plus 12, which is equal to 4. There we go. Okay, but that's only half of the problem. Now we need to find the first sum, or the sum of the first 13 terms. So let's plug all this back in. 13 divided by 2 times u1, oops, times u1, which is 4, plus u1 plus the common difference of -6. So let's subtract that. It's 12. That ends up equaling -416. There we go. All right, we're almost there. These exercises do take long, I'll say. 14, we're given that the sum of the arithmetic series is given by s, ooh, it's kind of small, Sn is equal to 6n minus 3n squared. We're told to find the common difference and the first 4 terms of the series. Okay. From here, it's actually easy to find the first 4 terms of the series because given that it's a series, that just means that if we plug 1 into that, we'll get the first term. And then if we plug 2 into it, we'll get the second term. So let's start with that. So S1 is equal to 6, 1 minus 3, 1 squared, which is equal to 3, which is equal to U1. S2 is going to be equal to 6, 2 minus 3, 2 squared, which is equal to 0. And we know that the sum of the second term, or the sum of the first 2 terms minus the sum of the first term is going to be equal to U2, because that's just subtracting the differences away from each other. And that's just equal to 0 minus 3, which is equal to -3. So there we go. We have U2 is equal to -3. So now we have a common difference here. U1 is equal to 3, U2 is equal to -3. If you look at that, the difference is going to be equal to -6. So that means the first four terms are just going to be 3, -3, then -6, -9, and -15. And I think that's all it asked for. Yep. Okay. That was 14? Yeah, it was 14. Okay. 15, our last one. I'll zoom in on this a bit. Okay. 15 is telling us to calculate the sum of all the positive odd numbers less than 300. Okay. Remember, the formula for odd numbers is given by 2n minus 1 such that n equals 1. So we need to remember that. We're told the sum of all these numbers, or we're supposed to find the sum of all these numbers. It's just going to be this little thing, dot, dot, dot. And it said up to 300. The first odd number right before 300 is 299. So that's going to be our nth term. And to find out how many terms are in this, we're just going to have to plug this into here, which is basically our u1 term in a way. So 2n minus 1 is equal to 299. So that means there's going to be 150 terms in this equation, or 150 odd numbers between 1 and 300. So let's go ahead and calculate using our formula right here. Summation of 150 terms is going to be equal to 150 divided by 2 times our first odd number plus our last odd number, which then equals 200 or 22,500. And there we go. That is exercise 1B, all said and done. We'll be doing 1C sooner or later. These videos do take forever to edit, and they take way longer to do than you would imagine. Geez, I will say that this unit is probably one of the hardest units in class, just because of the amount of work you have to do and the proofs. The proofs unit's going to be hard. So yeah,